Hey, welcome to another DraftScience video presentation. Mostly physics, though. Yeah, I'm sorry. It's just comments and just this task of reasoning on this planet of retarded aliens. I mean, that's what it just feels like. You're all just so fucking stupid. Can't relate to anybody just about. Just nonsense. It's everywhere. Anyway, I'll endeavor to persevere, but I don't like it. Don't like living on a retarded alien planet. Anyway, whatever the fuck this is. What the fuck is this shit? 0v0. I don't know. What the fuck does that mean? Oh, fuck. Anyway, then some asshole, Jocko Ferguson. I dispensed with you. You should go away. Anyway, so this is an old Ken Wheeler video he's commenting on. Let's see, the ferrocell. So Ken Wheeler says light is bent by the magnetism of the ferrocell. Complete nonsense. And proving it with, you just take a microscope and look at what the little bits are doing, and you can see there's no big surprises here. It's just light refraction, and it's an optical illusion, if you want to call it that. But no, nothing bends. But anyway, that's cool. Anyway, so this Jocko Ferguson, right? Went to his channel. He's got a whole playlist of how to build a pyramid to generate electricity. This is the kind of nuts that are making comments. I mean, fuck. Anyway, I honestly thought there was a lot more ignorant people out there. I don't know. Your evidence that you've got it right the first time. There are a lot of ignorant people out there, and you're one of them. Ugh. Ken's explanation of magnetism is better than any explanation there is. Well, it would be nice if you contrasted, provide the two explanations even. Conventional physics versus wacky Ken physics. Because, frankly, conventional physics makes a hell of a lot more sense. But what, you really think a magnet's just sitting there all day, creating this? Somehow it's making stuff do this, and then it's making this stuff do this, and there's another tornado going the opposite way down here. You really think it's doing that all day long? With its magical, underdog super energy pill? Fuck. Too stupid. I find it really fascinating. Well, of course you do, because you believe in some sort of pyramid magic. You're a dumb motherfucker. Anyway, you must have an agenda. Yeah, hating stupid. I really hate ignorance. And especially ignorance that's arrogant like you. Arrogant ignorance, where you're a dumbass. You ought to know you're a dumbass. You haven't obviously thought in any constructive way, like in any 5-minute period of your life where you actually said, oh, I'm going to be honest for a while and really look at something and see what it is rather than calling it magic. Because there's no way you could really think and be an actual physicist. So nowhere do I claim to be an actual physicist. I don't imply that I have a physics degree. But the fact that I have watched hundreds of physics lectures and am familiar with the material is just a fact, asshole. Where is there any evidence you've ever done that? Have you watched 10 minutes of the real physics from the real physicists, or have you just watched your little magical fairy people? Anyway, you really seriously don't know what coaxial means? Where did I indicate I didn't know what it means? I know what a coaxial cable is, okay? Ken Wheeler says light is like a coaxial cable. Well, in the first place, a coaxial cable doesn't go anywhere. It just sits there. So I don't even know how light could be anything like it, because light's going really fast somewhere. But if we're arguing that light somehow travels, like electricity travels through a coaxial cable, how can I even make sense out of it? Because we know the electrons are moving through the cable. There's a pressure, a force pressure that's pushing them. And we pile up at one end, and there's less of them at the other end, and that's sort of how it works. Or else you can push and pull, you know. You can take them away and add them with an alternating current. So is light alternating current, or is a light DC? Because I can put both into a coaxial cable. I mean, it's just such a stupid, insane analogy. How the fuck could light possibly be like a coaxial cable? It just doesn't make any sense at all. And even when Ken attempts to draw it, I mean, how the fuck can you write this comment and say it makes sense to you? You understand. You understand. So Ken Wheeler basically says that light, you know, he's taking the nodes and he's giving them, so he's giving light all this direction, but he's saying it's happening like it's a coaxial cable that's what, broken into a million zillion little pieces, and the light goes this way and the light goes that way, and somehow the whole node goes this way. So again, we have this swirly crap. So it just, the photon is a little swirly bit in space that ends up going this way at a preposterously and insanely fast speed. How does that make sense to you? I mean, how the fuck can you write this comment? I just don't understand how I could be on a planet with people who could write something this fucking stupid. How can this make sense to anybody? How does this make it understood that, well, what photons really are is energy, and energy that never stops. It goes into a system. Here's a system. The energy goes in, and guess what? It just doesn't die. It can stay in there for a while, la 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 la, but it always ends up coming back out again. We can follow this little thing. We can follow it around. It's had a history. It's right now the same energy, okay, that was flying into dinosaurs and heating them up, and the same little bits of photon, the same little bits of energy is still moving around here, you know, the same little chunks, and they've been doing things. They're inside a rock for 10,000 years, and the rock cools down a little bit, and gets into a little less pressure, and then it flies out, and it might even make it back to the surface of the earth. So go into the earth, and they could spend 10,000 years in there, or 10 million years in there, and then all of a sudden it finally gets released again. It's moving around in the atmosphere, and blah 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 blah, like a little piece of carbon. Little piece of carbon was floating around in the atmosphere, a little happy piece of carbon, and it gets stuck inside of an organism consuming it, and it stays inside, and then it doesn't quite decompose, so it doesn't get back into the atmosphere, and instead it gets buried by tons of geology. It ends up being oil in the ground for hundreds of millions of years, and then we pump it out one day and put it back in the atmosphere again. I mean, how do you think the universe works, you fucking crazy shit? I mean, I'm sorry, this guy, I wish I could, tie these people to a chair and rubber hose the truth out of them, because this is such a preposterous pile of shit. Who's got the agenda here? You're obviously some kind of fairy lover, okay, and Ken's a big, fat, fun fairy. For you to, you got some sort of homo thing going or whatever. You're out of your fucking mind is what you are. Oh, god damn. I mean, his theory of magnetism is insane. It's just fucking insane. I mean, he can't account for, he creates all this swirly shit, and there's still no way you can explain why magnets attract and they repel. There's just no explanation for the strong attraction and the strong repulsion. It makes no sense at all. It's gibberish, for fuck's sake. Stunning. Okay, that didn't go away either. So, way to go, YouTube. It's working well. Alright, so this is some DPUD 01. Okay. Or DAPI 01. I watch your videos often. I hope you succeed in your endeavor for a better, more proof-based understanding of mechanics of universe. I'd just like to have a rational argument about something. I mean, Sean Carroll did his atom video, right? There's no atoms in the video. I mean, it's all muons, buons, gluons, stuons, all this shit that plays no role. They couldn't ever draw a picture of how this atom works. I mean, they know the electrons and protons are the only active players. There's no other active player. That's it. Electron, proton together make a neutron. What? There's no other crap necessary. Anyway, and you know that from their own accelerator experiments, that the only way you ever see these idiotic, stupid particles is if you smash things and you see them for a millisecond. And again, whether you're seeing anything at all is the real, obviously I would just say you're seeing the same electrons and protons, you've just pushed them. This is just so stupid anyway. But you can't even respond to it because it's just such a pile of fucking shit. Anyway, is there a fundamental difference according to you? I point out explicitly in the video what the difference is. And I get asked this stupid fucking question regarding the gravitational force acting on a person as an action force and the earth pushing back with an equal but opposite reaction force on the one hand, and the rocket man, this is a bit of a run-on sentence, being pushed under his feet by a small rocket engine providing an action force that is causing him to accelerate with exactly 1g further into space. On the other hand, whatever. He's going the awful long way around to say, is there a difference between gravity, the force that's pushing you down, and the force that's pushing you up? And I obviously pointed out you feel the force pushing you up. You never feel the one pushing you down. I made it explicit. Is that a huge difference right there, feeling something? Yeah, it's a pretty big difference. I could compare it to shooting a bullet, all right? That has a certain amount of energy. I can take the same amount of energy and make a big giant ball of feathers, and I can swing the big giant ball of feathers into you and hit you with the same amount of energy. Now, one of them's going to bore a hole in you and your blood's going to leak out. The other one's going to give you a warm, fuzzy feeling. Ooh, that was fun. Big difference. Having your atoms pushed, okay, all of them at the same time almost. Gravity can't go infinitely deep. So if you were really, really big, it would take a while for gravity to also get through all your atoms. It would be moving your head atoms faster than your feet atoms. But the point is it's a tiny, tiny little rain that's hitting everything versus one big raindrop that bores a hole in you. You can't see the difference between those two, or it forces your atoms to be displaced. Well, it's probably worth saying it again. I said this shit in the video, for fuck's sake. I just shouldn't have to do this. Just people, I watch your videos. Well, you don't pay any fucking attention. I do speak fairly good English. I'm fairly explicit. Atoms, okay, are somewhere. Now, if I move them all at the same time, that is, I push them all at the same time, all the energy goes this way, right? So if I hit them with some little tiny ultra-mundane force and they all get hit by the force, they'll all move collectively, and they won't have to bang into each other or bump into each other or do any of that stuff. All their forces will remain the same, and they'll all just be slid to a new place in space. But if I apply the force, okay, on just one of the atoms, and the atoms are all stuck together, well, then this atom goes out here, and that causes a disturbance because this one has to fill that void because the energy dynamics change, and this one has to fill it. And so now they start moving, right? The atoms start moving this way, and they move this way, and the one this one banged into might move that way, and it might move that way, and it might move this way, and it might move this way. So you can see the energy is incredibly inefficient in going through the object. It heats it up a lot more because it's causing a lot of movement in directions that aren't going to be this way. So it's going to take it a lot longer to apply the force. You're going to acquire your acceleration over a much longer period of time. Okay, the time is going to be much longer. all right, for the force to accelerate you, because you have to do all of this banging into of the atoms and going all kinds of, the atoms have to go in directions, and they, you know, if it's a solid material, it'll stay, it keeps its structure, and so it's more efficient. But if it's a semi-soft material, you know what happens, it expands this way, right? I push it this way, it expands this way, contracts this way. So lots of waste, lots of inefficiency in applying the acceleration. So, I mean, I made this point. This is a highly efficient acceleration. You don't feel it, gravity. So if I remove the ground, you're not going to feel a damn thing. Okay, you will feel the sensations, the anti-sensations, in the sense that, you know, we're used to being in gravity. So when there's no gravity, your stomach feels weird. Things feel weird because there's no gravity pushing your guts down anymore. But I just mean you don't feel it in any other way. There's no, you know, there's no bending of your body and all the other things that take place when you're being pushed up. So completely different in terms of the efficiency through which the energy, the direction, is applied. In the gravity case, all of the gravity is pretty effective at causing action in this direction. In this case, the acceleration is very inefficient. Lots of other shit can happen, and it takes definitely time at a minimum to apply the acceleration, because you're spending a lot of time forcing things to move in directions that you're not going on purpose by application of the force. Alright, wherever the fuck I was in this mush. Okay, exactly one. Okay, where's the end of a period here? I can't even find the end of a sentence here somewhere. That's causing him to accelerate with exactly 1g. Okay, we did that. A reaction force he feels when standing on Earth. So his feet should feel the same force or pressure in both situations. So I guess you just don't understand. How would you feel it the same? The thing that's pushing your individual atoms and a thing that forces some atoms to move a lot and forces the energy to move through all of the atoms by, you know, the pressure between the atoms. All right, more interesting is what's the Rocket Man is experiencing himself. More interesting is what the Rocket Man is experiencing himself. How is it interesting? It's duplicating one of the forces we're involved with, in terms of the force back up being pushed by your feet or your ass. How is that interesting? Okay. If the reaction force caused by the inertia, so fuck inertia is a silly word. There's no fucking such thing as an inertia. It can't cause anything. Okay. By the inertia is action upon every little piece of the Rocket Man. So again, it's not every little piece. It has to go through your feet, through the cells on your body, the outside cells first, and has to migrate through chemical pressure between the bonds, molecular pressure, atomic pressure between the atoms. That's where it has to be transferred. The individual atoms are not pushed. They're not feeling any of the raindrops. Okay, then he will probably experience no different force effect than the effect of gravity had on his body and senses. So being pushed physically by, like a bullet, or being hit by a bag of feathers is the same thing. No, it really isn't. The more you can distribute the force, the more surface area, right? So we're talking about a surface area, and then the point of gravity is that it's like X-rays. It goes right through you, fucker. So the gravity's hitting lots of pieces directly. So it's not only just hitting more surface area, it's hitting it deeper and deeper and deeper. Anyway, when he is still on Earth. In other words, is there a fundamental difference between a gravitational action force of 1g and the force induced by inertia? a 1g acceleration. Thanks for your response. Well, I mean, it was already in the video, but let's see if there's this. I mean, there's no, like I said, I gave analogies, and I've done this and been there and done this, and there's no point in. First off, let's understand gravity is the absence of force. Okay, so gravity has to be understood as just being a phenomenon. And the real argument is that what happens in gravity is that there's a force on you in balance. And then that force, okay, if there's matter here, okay, if this is matter, then some of this force will be occupied moving this matter. And by being occupied moving inside this matter, it's not going to get to you. So you have more rain hitting you from the top than the bottom. So gravity is just an absence of force below you, not more force above you. But it turns out to be obviously equivalent. So the point is that the gravity, okay, is going into every bit of you. So this cell, this cell, this cell, all the atoms are here, and I'm saying the gravity is going to hit each one of them. Okay, it's going to get to all of them, and even through the force, it gets through them in the sense that if the same gravity hits this one, and then another piece hits it, and another piece hits it, another piece hits it, all of those pieces of energy will add more momentum to the piece. And so the energy just gets through to everything much more efficiently than if I tried to apply the force by just hitting these surface ones. And obviously if I only hit 10 of these surface ones, right, just the bottom of your feet, the small number, then all of the energy has to be migrated by the chemical pressure. And so that means the atoms have to bump into the atoms and blah, 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 blah. And it's a lot more inefficient in the sense that you'll cause a lot of this direction versus this direction. I mean, I explained it. So yeah, they're fundamentally different applications of the force. This one's going through your material like an X-ray and hitting everything. This one's just hitting your feet. Just delete it, but fuck. So I don't even know if I answered this one, but this is stupid. Have you tried contacting any established physicists? Yes, of course, over and over and over again. Yes, I've offered them money. I've contacted their people, okay, and tried to get a price list for an hour of the physicist's time. But clearly it's not to their advantage to play with fire, and I am fire to their mushy, cruddy, silly jello. If you cast a wide enough net, you might catch some. Yeah, thanks for the advice. Sure, great. Maybe you should watch more videos, because frankly I've been over the subject a lot of times. But whatever. Anyway, so none of these did what they were supposed to do. Let's see if they are deleted. You know, no, they're not. So thank you, YouTube, for not working very well. So this one was just hide, because that's just too stupid, that gibberish. Okay, so we'll go through this again. This asshole will just remove this to see if he has some kind of comeback, like why he thinks it's so fascinating, all this magical swirly shit. Oh, look at this. They added more crap 36 minutes ago. Oh, jeez. Oh, fuck. Well, anyway. Liabilities of being on the internet. By the way, I didn't saw the whole video yet. Oh, great. I just love when people comment without watching the fucking video. So I will revisit it for sure. Fuck you. Fuck you. Yeah. So, yes, he didn't get to the part where I explained the difference, you fuckhead. Alright, because I want to learn more about the bent light idea and its possible flaws. but not today or tomorrow. You'll get around to it sometime. Anyway, I myself think, who cares? The Rocket Man will not feel the difference because the sense organ. So he hasn't watched the video and he's going to make a counter argument. Oh, I just think you're swell. Fucking asshole. I mean, who does this? Who thinks this is a rational way to interact with other human beings? I will not listen to you and then just talk my shit instead. Fuck. In his feet, inner ear, and whole body are fully adapted. It doesn't mean anything. Also in the evolutionary sense, and familiar with 1G situation. Yeah, they are, but the fact is that you can jump out of an airplane in free fall, and you won't feel all that disturbed. But the two situations are totally different, as you pointed out. Well, there you go. So why did you ask me how they're different when you just agreed they're totally different? They're not actually totally different. They're just different in terms of how efficiently the accelerating force is applied to the object. It's more efficient if you move the atoms directly than forcing the atoms to bang into each other to convey the force, because the atoms are more likely to move in directions not immediately heading in the right way. Alright, for example, oh fuck you, if the Rocket Man would jump stress up from the rocket's, let's say, first floor, his legs will feel the same reaction force from the floor, and his inner ear will register the same acceleration. But beyond the highest point of his jump, after he decelerates back to zero acceleration, well, he won't be zero if he's in an accelerating rocket, which he will feel as such. The Rocket Man will not experience any feeling of falling because the absence of Earth gravity. But the ship is still moving and it's going to hit him. So he doesn't need to feel anything. But yes, he won't be in any gravity. That's the truth. He feels weightless until the rocket catches up with him and starts pushing him again. Yes, that's right. With 1G, well, whatever, it doesn't matter, 1G, 10Gs, whatever. And he becomes physically a passenger again. But again, he's not a passenger in any benign way. The rocket, the chair keeps pushing. The floor keeps pushing. You constantly are feeling the pressure being applied to your feet or your ass when you're accelerating. Okay, again, after the unpleasantly rough encounter with the lower floor of the rocket, it won't be any more unpleasant than when you jump on Earth. So, but whatever. Oh, God, it's just so tedious. I do not really like people. So, yeah, we'll get rid of this. Have you asked? Yeah, I have. Tried bribing, and you can't get any of these. You know, I said the thing about Ken Wheeler. Screaming fucking coward. Why didn't you point that out in your comment, shit for brain? If Ken Wheeler is so right and so logical and it's so clear, why is he such a fucking coward? Oh, speaking of cowards. Anyway, Piro, yeah, it is kind of funny. You know, I left a comment on Piro's thing inviting him to do a Skype. And I never got a reply, and now the comment's gone on his video. But, you know, maybe I'll reply to this comment. Maybe you'll see that. I don't know. But he's really too far gone, and now he's doing the Discord thing. You know, I don't know why people find Discord fascinating at all. More noise, less signal. I mean, nobody makes anything called a direct argument. I mean, Piro laments they took away the video response link. Yeah, all they took away was the video response link. They didn't take away your ability to make response videos. So again, it's just hilarious, and you suck at it, frankly, Piro, because you don't actually respond to what people say. You respond to some crap you make up about what they said. Anyway, so just too pointless. All right, well, since there's just absolutely nothing going on, I mean, there really is no videos, anybody, there's just nothing to respond to, nothing, no coherent conversation about the nature of anything. It's all just people spewing their propaganda. So I figure I did a YouTube search for physics, and you get a bunch of Spider-Man action figure kind of crap, and it's all supposed to be something, the physics of something, but I don't know what the fuck it is. And then you get all this stuff in Hindi, and so 1 in 100 videos on the subject of physics is something in English that's physics, So one of them turned out to be Physics Girl, so I figure we'll play some of these over time. And I'm sure there'll be plenty to mock and make fun of as just horse shit. So we'll do one of those and get the fuck out of here. Oh, forced ad. So it's like they don't even give you the voluntary ads anymore.
There's never been a better time to save with Geico.
Yep. Tacky.
Thanks to Curiosity Stream for supporting PBS Digital Studios. Whoa! It looks like I'm wearing really bad tanning oil.
Oh, whoa! Anyway, I think I have the setting. Well, 1.5 is okay. We can live with that.
Hey, I'm Diana. You're watching Physics Girl, just relaxing here in the shade on this beautiful summer day. Isn't that right, Derek?
Yeah, that's right, Diana.
Okay, but you're not needed for this video yet, so you just chill. So a couple months ago, a few guys got in touch with me and told me that they had access to a UV camera. Do you know what that is?
Yes.
Basically, it's a camera that allows you to see the world in ultraviolet, which meant...
Oh, gee, that's just, it's only invented, 47 years ago?
A few things for me. It meant that I could see what this looks like in UV. I could see what your face looks like without any lotion or makeup on in UV.
So it really doesn't look like that, in the sense that there's no gradations. Well, I guess the gradation of ultraviolet, but it's a huge range, and you're looking at one specific target frequency probably. So I mean, it does look pretty black and white.
And I could see how sunscreen shows up on your face in ultraviolet. And so I said, yes, please do come visit me in San Diego and bring your UV camera. And so the guys from the very well-made YouTube channel, How to Make Everything, showed up at my house. This is
just more of this YouTube buddy network kind of horse shit that I'll promote you, you promote me, blah, 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 blah. I mean, it's all just part of how dishonest everybody is. Look, I'm fake friends. Maybe me and Ken could be fake friends. If I had more subscribers, he'd go for it, probably. Let's be fake friends.
What we did.
Yeah, on your pants. Your pants are so tight right now.
You have some weird tan lines after this.
I was just thinking that.
This is so crazy.
Ooh, those are devil horns. Yeah, bigger the better. Yes, me. Whoa.
Oh, this is really horrible, right? I mean, this is Physics Girl. I mean, this is real physics stuff, right?
I gotta see this.
Let's make it a cartoon. Let's not do a serious experiment.
Is that showing up?
Oh, yeah.
Oh, yeah.
Nuts.
What? Yeah, that was a fun day. But I should explain why I'm here with Derek from Veritasium, who is also making a video about the world in UV.
I've been making this video for like a year.
So networking some more. Oh, fuck. All right, so Veritasium, like I said, I didn't have too much disregard for him being a liar and a gimmick player and a whatever. But now thinking about it, the single photon experiment he did, it just screamed at me all of a sudden, the realization that he did engineer the results, in the sense that there's an old 1950s experiment where they're detecting muons. So I've been over this, but I just want to emphasize the point, because these people really just don't have much credibility, because I think Veritasium found out that, hey, this photon shit doesn't work. I mean, this magical single photon experiment, it doesn't work. And he had to force it to work, okay, because it didn't work in some sort of natural way. So the idea is you have a photo detector, right? And you can detect light with these photo multipliers. And the simple truth is you can change their sensitivity. You can make them very sensitive or less sensitive. And so in the old 50s experiment, they're detecting muons based on the fact that when they crash through a scintillator, a piece of plastic, they hit an atom and they give off a photon. Okay. Now, in the 1950s, they were able to have a photo detector that didn't get any error photons. No fake photons got in here. So, the only photons they counted were actual count of photons that actually were made in the scintillator. Now, when Veritasium did his bullshit experiment detecting single photons at a time, for some reason, okay, he had the photomultiplier turned way up sensitivity-wise. Okay, so even in a dark, completely sealed container, it was still picking up 5 to 7 fake photons. Okay, and they're not fake in the sense that what they really are is the energy of the universe getting through. But he has it, you really can't, the photomultiplier won't see that radiation unless you have its sensitivity turned way up. So he did the experiment with the sensitivity way up. And why would he do that? I mean, he has a controlled light source. He's sending real visible light photons into the experiment, right? So he has no reason to have the sensitivity way up. He has every reason to have it turned as low as possible to make sure he's seeing big, giant, visible photons and not seeing any other kind of radiation. And, so, I mean, just these presenters of physics, again, I'm telling you, they're engineering the experiments. They're quote mining the evidence. They're forcing it to fit. They're not saying, they're not making an honest statement. They're not honestly describing the fact that, oh yeah, I tried it with the sensitivity down, and guess what? I didn't get any pattern. Yeah, no pattern. Nothing came through the two slits. I didn't get any photons. I bet you that's the honest truth. Because there's really no reason for him to have it turned up that sensitive. He knows what he's looking for. He's looking for visible photons, big, giant, visible photons. No reason to have it turned way the hell up.
And I'm here to make him finish it. But for this video, we're going to cut in a few times to discuss the sunscreen controversies.
There are a lot of misconceptions about sunscreens, and we're going to clear them up.
Yeah, but for now, I'm going to turn it over to Diana in
Oh, fuck.
the studio.
Back to you, Diana.
The first thing I wanted to look into was whether different SPFs, that is sun protection factor, which actually is supposed to indicate how strong the sunscreen is. But anyways, I wanted to see whether different SPFs of sunscreen look different under UV light. And then I wanted to compare whether high SPFs, like SPF 100, are more effective than just regular high SPFs, like SPF 50. Here was my thinking. With a UV camera, things that look lighter are emitting or reflecting UV light, like the wall behind us. And things that look darker, like the shirt that I'm wearing, are absorbing UV light, which is something that I think you'd want to...
Yeah, I know, but if the fluid is doing the absorbing, it's still protecting your skin, so it's not a very good way to detect whether the stuff works or not. Because if it does heat the oil that's on the surface and is absorbed, well then it did the same thing. And it could also be working by converting the UV into infrared or some other kind of radiation. So it might even work like little magical crystals. It might be changing the frequency of the light, making it passive, more benign.
know when it comes to sunscreen, because UV light, ultraviolet light, of course, is part of the spectrum of light or electromagnetic waves from the sun, and UV is just on the far side of the violet part of the visible light rainbow, which means it's a wave that has a shorter wavelength, which means it has a higher...
Okay, so they drew this completely wrong. So we already have a flaw. Because their understanding sucks. So the truth is that if you want to draw these two accurately, okay, first off, they don't have these waves. The ultraviolet is half the frequency in the sense that it's twice as much stuff in the same space. So if you have a certain amount of space and you're going to draw it, ultraviolet light would pretty much be twice as many of those little humps as infrared. So infrared would be, like this by comparison. huge difference. The more important thing that's missing is an understanding of the fact that you also are, because polarization is proportional. Camera. Quit doing that. Oh, that doesn't help me at all. What the hell is wrong with this? Everything requires maintenance. Who has time for that? Yeah. Stay. Stupid fucking cord. This is obviously somebody else's fault. I'm not taking responsibility. Alright, that's probably close enough. I have to do. Alright, so the idea is that they should be drawing it, understanding that the other element to this wave thing, okay? So let's say that's the blue light, and this is going to be the red light, okay? Right? That's exactly what they did. The red light's polarization is twice the blue light. So yeah, you draw the waves, less frequency, here, and its polarization is much bigger. So it means when it hits a surface, the blue light has more little hunks in it. Okay? Plus, so there's more bits hitting, and they're hitting a smaller area of a surface because their polarization is narrower. So those are two factors to the difference between ultraviolet and infrared. And clearly neither one of them is accurately represented there, and certainly showing the red light as little humps is very deceptive in the sense that it doesn't show the fact that the red light, okay, is going to hit a bigger surface area.
Frequency than any visible light, and in the end it can do more damage to molecules like DNA or to cells. And as we all know, it's been linked to skin cancer. So my thinking was that if you look at your skin with sunscreen on, you should see that UV light is absorbed, so it should look darker. And yeah, like when we put the sunscreen on, it looked like face paint. We were even able to graffiti the side of the truck with sunscreen, but of course you can only see it with the UV camera. So my hypothesis was that the sunscreen with the highest SPF should look darker with the UV camera. And so we tested a bunch of different sunscreens with different SPFs on a grid on my arm, drawn with permanent marker. Here's what we saw.
You can't see anything.
Oh wow, it looks like paint.
Yeah.
Looks like metallic black paint. Initially, we saw that, yeah, the low SPF areas do look less dark. You can tell they don't seem to be absorbing as much ultraviolet light. But interestingly, there's not a ton of difference between the 30 to 110 SPFs. And I've heard this rumor that SPFs above 50, anything really high, doesn't actually do anything more than SPF 50. So I looked into the scientific literature on this, and I actually found a study that came out just this year, in May 2018, that tested 100...
Oh, yeah, so they did the same thing you did, and they just found out that, companies love to lie when they can get away with it. Yeah, they love to do that.
99 people with SPF 50 and SPF 100 sunscreens. Over the course of about 6 hours of sun exposure, the subjects got more sunburnt with the SPF 50. But they do put a nice little disclaimer at the bottom of the paper that leads you to conclude that more research needs to be done on whether there are more benefits over the long term of using SPF 100 versus 50. Hey guys, I just want to pause on this for a second, because I still think it's weird that I have this conception that above SPF 50 you don't get any more benefits. And Derek, let me know what you think about this. But I think I figured out where that conception came from.
Okay, so they're just spitballing here. I would argue that the difference is that you're not counting the amount of photons the substance is absorbing. So the ones that stay gooey and liquid, they absorb more energy. They can absorb more energy.
And I think that it's from a 2011 proposed rule from the FDA, the American Federal Drug Administration. Yeah, they proposed a rule that would limit the maximum allowed SPF labeling to 50 plus. Thoughts?
I also don't think it's strange, the conception that the high number sunscreens are all basically equivalent. When I lived in Australia, people were limited to putting only 30 plus on the sunscreen bottles, and now they've moved that up to 50 plus. But it's still, I think, a good idea, because as those numbers increase, you're getting kind of diminishing returns. So what's the difference between 50 and 100? Well, it's not really that much.
Well, the guy they did, so they just ignored the fact that they did the thing and found that they did get more tanned or sunburned with the 50 versus the 100. So it's doing something. It's not doing as much, but it's doing something.
A lot of how effective they are comes down to how much you apply and how well you apply it. So, I think it's just a marketing gimmick to say that, like, this is a 75, or this is an 80, or this is a 90.
So obviously, SPF and the efficacy of different sun protection factors is still an active area of research. Anyways, back to the fun day at hand. When we were looking at the sunscreens with the different SPFs, we tried a different sunscreen with SPF 25, and something weird happened. It was actually lighter, like really light. This means that it's not absorbing UV light, but could it still be sunscreening? Yes, if it reflects UV light, which is most likely what's happening here with this sunscreen that has zinc oxide in it, which is a substance that's known to reflect some types of UV light. So, this is where I got really confused. I started looking up some sunscreen ingredients and what they do, and why some are reflective and others are absorptive, and I ended up going down the rabbit hole of sunscreen controversies. I'll get to the discussion on health effects of different sunscreen ingredients.
So yeah, so what's the point, right? There's more than one way to block the radiation. You can absorb it or you can reflect it and not transmit it. So it's like a glass argument or something. You can have different materials that will transmit light, only specific light, and then the other light, they'll reflect it or they'll absorb it in heat.
In a minute. But I did find that Hawaii recently banned some sunscreens from the state. The reason why is that the ingredients oxybenzone and octinoxate were found to be contributing to coral reef bleaching, a process whereby coral polyps expel the little algae living inside of them. Actually kind of sounds like an exorcism, but it is in fact a bad thing. So starting in 2021, Hawaii is banning any sunscreens with those ingredients. This ban was based off of recent research, which begs the question, are the health effects and environmental effects of sunscreen ingredients not well known? Okay, I'm just going to pause here again because I feel like this is a good discussion for us. There's a lot to unpack.
Right, they're oils usually, and oils float on the water, and so I guess that's the problem
here, but I want to start out with that SPF 25 sunscreen that was really reflective.
Yeah, I mean, there's two major ways that sunscreens can protect your skin from UV light. One of the ways is by absorbing that light and turning that energy into heat. Another way is by reflecting the light. And what you saw was clearly more reflection. Now, in the media, they're often called physical versus chemical sunscreens, which is maybe not the best designation.
I don't think it's the best.
Because, they are all chemicals. Maybe it's...
Right, so the zinc oxide is obviously very opaque to your eyes. So obviously it's just putting like lead on your skin, so you can't get through it.
It's a better distinction to say that the chemical sunscreens are organic because they are organic molecules that have these chains of carbon, and the so-called physical sunscreens are inorganic molecules, things like titanium dioxide and zinc oxide. So they do a bit more reflection, but they also do scatter the light, they absorb the light.
This chemical versus physical distinction bothers me, as you know, because I think it's used in a misleading way on a lot of...
So this really doesn't have anything to do with light, it's how it's structured, or what it is. Just has to do with different chemical ways to affect light.
Health blogs and in a lot of media indicating you should avoid these chemical sunscreens because they're chemicals.
You don't like it?
I don't like it.
Because they're all chemicals.
Right.
Everything's a chemical.
Right.
I think there is sort of a deeper reason why people would say chemical versus physical, because chemical could describe, like, by virtue of its chemistry, that's how it
Yeah, well, I guess the difference is that how inert is it? Like titanium oxide is pretty elemental, so most of the elements our body has been exposed to, and it knows how to deal with elements. But it's not too good when you make compounds, because then they can trick your skin and get into your skin and transmit through your skin.
interacts with the light. Whereas, a physical sunscreen, by virtue of its structure, is really how it interacts with the light. You're right, when it comes to the marketing, people do try to use the chemical label as sort of a negative term.
And I think that it actually hides an important discussion about the potential safety issues of what they call chemical sunscreens. So we're discovering things about sunscreen ingredients all the time. For example, recent research has shown that some sunscreen ingredients, and in particular some of the organic sunscreen ingredients, can get into the bloodstream and into breast milk through your...
Yes, exactly what I just said. Yeah, it's ironic, but yes, some of the stuff that's less elemental, like I said, our body knows not to absorb, like even arsenic and stuff. Your skin is a good protector against a lot of stuff, but if you change the chemistry a little bit, and then it has a little key, a little trigger on it that fools the skin, and then the skin will let it pass through.
Which led the FDA to recently state that this is a significant discovery that needs to be considered as we continue to evaluate the health and safety of sunscreen ingredients. In fact, the FDA just recently rejected 8 new proposed sunscreen ingredients
because they felt there wasn't enough science to show that these ingredients were safe.
But my question is that now that we know sunscreen ingredients can enter the body through the skin, should we be looking back at those 16 ingredients? Should we be looking at them through the lens of the new research and judging them with the same thoroughness that we're judging these 8 new ingredients against, for example?
What's surprising to me is that there is still so much to be learned about sunscreen. I think it's a
They're like midgets. They don't fit on their couch.
a little weird because on the one hand, you're saying these health blogs are saying chemicals bad, but on the other, you're saying, well, maybe chemicals are bad because they haven't been really tested yet.
That's not why people are saying that they're bad. And in fact, some of them may be perfectly fine, and they get lumped in with the ones that do cause skin allergies. Like, to say because they're chemicals is the reason, like, you might lose out on potentially a ton of great sunscreen ingredients that are going to be really effective for protecting the populace against skin cancer, but people have lumped them into this chemical category, which really just means...
No, it'd be better is to pay attention to your genetics and maybe try to become immune to these things. You know, if we did a little bit of genetic engineering, you know, we could make this a lot simpler. But instead we're doing the opposite. Let's all rely on crutches, you know, and walkers, and you know, let's all just be totally dependent on fixing our genetics with our bad genetics instead of making the genetics better. But anyway, I mean, you breeders just have no ethics at all. You don't want to make your kids better. You just don't care, frankly. But anyway.
Organic molecule category. Maybe we're going to find ones that don't get absorbed into the bloodstream as readily. You know what I mean?
Yeah.
There is so much to be learned.
But at the end of the day, I think...
Mud, dirt. Yeah, just get really dirty, and then you won't get a sunburn. Do what you need to do.
Put on the sunscreen.
At the end of the day, do you want skin cancer?
Because it is the most common cancer in the U.S.
Yeah, so what? It's also the most curable and all that kind of crap. And what are you going to do? Live forever anyway? You know, if you're going to get cancer from the sun, just give up. Forget it. All right, let's all just quit. Stupid.
From the man. Wear sunscreen, kids. Oh, well, yeah, also thank you for watching this video. And check out Derek's video, which is going to be about...
The world in UV. Something about sunscreen, but about everything else, too.
Really cool experiments that we
Oh, yes. Really cool. All really cool and fun.
filmed yesterday. Check out the video by the How to Make Everything guys. They made sunscreen in the end.
Did they?
Yeah.
Awesome.
Yeah.
I watched that.
I will link to both of those videos in the description and at the end of this video or whatever. Thanks so much for watching. And
Yes, we're just doing our little networking thing, our little YouTube buddy thing. Yeah.
happy physicsing.
Thanks to Curiosity Stream for supporting PBS Digital Studios.
Yes, more commercials. More selling of product. Oh, look at all this crap. Buy Physics Girl merchandise. Look how cool it is. I can't wait to get one of those for myself. It's only $25. What does it say? Science. Science! It's for every Adam and Eve. Oh, that's fun. I have to sign in to buy something now? God damn. Oh, God, I hate this planet. I just hate it. Who would wear this? It's for every Adam and Eve? What the fuck? What does that even mean? Is that just some... You know, why don't you just say, and queer? You know, what the fuck is this shit? Oh, God, I hate this planet. I just hate it, hate it, hate it. Shit. Okay, anyway, so that sucked. So hopefully we'll pick a better one next time. I don't know when the next time will be, but whatever. But yes, there was no physics of light in that fucking video. So anyway, sorry, I'm just sick of, just sick of stupid, and it's everywhere. Fuck. No. I just had a relaxing moment. I need to do that now and then. So, till the next next video. Yeah. Till the next time, let's just say that.